A warm welcome to one and all. This is Dr.C.Madhumathi, Assistant Professor, Department of BCA, Bishop Heber College, Trichy. Today we are going to see about the data structure, that is exclusively about the stack data structure. This is a schema of my presentation. Today we are going to see about the introduction, the types of the data structure, operations that is performed on any data structure, stack, the real-time examples of stack, the operations of functions performed in the stack, the push procedure, the pop procedure, and the conclusion, and finally the summary. So introduction. So we all know what is data. So what is a data? It is a raw elements, that is it consists of the unprocessed information. It is a value. So in everyday every day there is a data has been keep on rising. Okay, so only with that data we can't do anything. So we want to process the data. So after processing the data, we obtain the information. So what is a data structure? Data structure is nothing but the logical or mathematical arrangement of data. So how the data has been represented in the memory, what kind of structure the data has been placed in the memory is known to be as your data structure. So these are the types of data structure. So the data has been located in the memory either in the sequential order or in the non-sequential order. The sequential order in the sense the data will be placed in a continuous way. So one after the other. Non-sequential or non-linear is that the data will be placed at the random in the memory. So these are the different types of the linear or sequential representation of data in the memory. So here you can see that array, stack, queue. So array, stack, queue and the linked list comes under the linear data structure. This is that non-linear or non-sequential representation of data in the memory. So the trees and the graphs comes under the non-linear or non-sequential representation of the data in the memory. So these are the types of the data structure. Next, what are the operations that could be performed on any linear data structures? So what are the linear data structures? The stacks, queue, array and the linked list comes under the linear data structure. So here we are going to see about what are the operations that could be performed on any linear data structure. So first one is a traversal. That is, traversal is nothing but processing each element in the stack or the queue or the linked list. It is known to be as your traversal. So next, searching. Searching is nothing but finding the location of the element with a given value or the key. So the key will be given. Based on this, we will find the location, we will search at the location of the element in the given list, in the given data structure. So next is that insertion. Insertion is that adding new element. So deletion is that removing an element. So sorting. Sorting is that arranging the elements in some type of order. Either it can be an ascending order or either it can be an descending order. So it arranges the elements in some order. Next comes finally the merging. Merging is that combining two lists into a single list. So next, what is a stack? Now we are going to exclusively see about the stack data structure. So even though there are array, queue and linked list and stack is there, mainly the stack data structure is being widely used in many of the applications in computer science. So it is now needed to know about the stack data structure. So here we can see a stack of books. So linear structures, what is stack? Stack is that it comes under the linear data structure. So linear structure in which the items are added or removed at only one end. So that we can add the items and we can remove the items at only one end, and that end is known to be as your top of the stack. So this stack can also be said as LIFO, that is last item that is added to the stack will be the first item to be removed from the stack. We can also say it in another term as FILO, that is first item that is inside the stack is the last one that is to be removed from the stack. So the last item added to the stack is the first item to be removed from the stack. So the stack can also be said as LIFO or FILO. So there are also other names for the stacks, that is piles and the push down list. So stack consists of a list of elements in which an element may be inserted or deleted at only one end, and that end is called the top of the stack. So here the elements are removed from the stack in the reverse order in which they are inserted into the stack. So it is a very restricted type of data structure. As I told you, it has many important applications in computer science. So here you can see that this is a stack data structure in which A, B and C are the elements of the stack, in which in this stack the insertions and deletion can be taken place at only one end, and that end is known to be as the top of the stack. So we can see in detail about how to insert, how to delete an element from the stack. Next, we are going to see some real-time examples as well as some of the applications in which stack data structure is used in our day-to-day life activities. So first comes the stack of bangles. We all wear bangles. Okay, so after placing this kind of bangles, if you want to remove, or how could we remove this? The last bangle that we wore must be removed first. So it is one such examples of the stack data structure. So next comes the stack of dishes. So here we can see that the dishes are placed in a stack. So the first dish that we remove is the last one that is being placed here will be removed the first. So it is an example for the stack data structure. So next comes the stack of pennies. So the pennies, so the last one that you placed in this will be removed first. So this is an example for the stack data structure. Next is the stack of folded towels. So here you can see that the last towel that is being inserted will be the first one to be removed from the stack. So in the computer science, we all most probably use word applications. Okay, so the stack plays a major role in this word also. We most of the times we use the undo and the redo operations in a Word document. Okay, so that is being done by means of the stack data structure. So undo operation, so the last action that we perform will be undone. So redo is that the last action that we perform will be again done. So this undo or redo operation, the main thing that is used here is your stack data structure. We unknowingly use all these kind of undo redo operation in our day-to-day life, but all these implies the stack data structure. So next comes the back button in browsers. Most of the time we will be surfing, we will be searching everything in our browsers such as Google Chrome, Mozilla Firefox and etc. etc. So in all these browsers you can see the back button. So back button, so the last web page that you visited, that we visited will be the one that is to be opened. So the back buttons is also an application in which the stack data structure is being used. So next, evaluating a mathematical expressions. In order to evaluate the expression, we need to place every expression in the data structure and then we calculate it and then we'll process it. So next, maintaining function calls in pointers. So in compilers. The compilers, what they used to do is, what are the functions that is used in our program will be stored in a stack data structure. So it will be easy to remove. The last function that is inserted will be the first function to be called. So next, reversing a string. So here you can see the given string is that welcome. If we place this string in a stack data structure, the one we get will be the reversed order. For example, if we place the welcome string in the stack data structure, it will be removed from, when we remove it, we will be getting the reversal of the string. So these are the various real-time examples as well as the applications in which the stack data structure is being widely used. So here comes the operations of functions that is performed in the stack. So create of S is that it creates S as an empty stack. So next, add of I comma S is that it insert or push an element I onto the stack S and it returns a new stack. So next, delete of S is that it removes or pops the element of the stack and returns a new stack. So next, top of S is that it returns the top element of the stack S. So next is empty of S is that the stack S is verified whether it is empty or not. If it is empty, it returns a boolean value true, or else it returns a boolean value false. Next is full of S is that the stack S is verified whether it is full or not. If it is full, it returns the boolean value true, or else it returns a boolean value false. So these are the operations of functions that could be performed in the stack. So the insertion is known to be as your push and the deletion is known to be as your pop. So the element that is the last element can be the last element that is known to be as your top of the stack. So here comes the push procedure or the algorithm. So here you can see that push, the parameters that is used is the name of the stack, top is the top position of the stack, max stack is the number of elements that can be inserted in the stack, that is the maximum size of the stack. And here is that item, so push is that insertion, so which item is to be inserted into the stack is that the item. So next, if top is equal to maximum stack, so the value of the top and the max stack, that is size of the stack, if it is equal, then it prints that the stack is full. Next, if the top and the maximum stack is not the same, then the top value will be incremented by 1. So set top is equal to top plus 1, it increments the top value 1. So next, the item will be inserted on the stack of top. So finally the return. So this is that push procedure or algorithm. Next I will show you the demonstration of how it is being inserted in the stack. So here you can see it is an empty stack. So the top position will be here. Okay. So next we are going to push an item A onto the stack. So first it checks whether it is an empty stack. So then what happens? The item A is pushed onto the stack. So then now you can see that top is being incremented by 1. So here you can see the top is here. After it increments the top value and then it pushes the item A onto the stack. So next you can see that the top value is incremented from here to here, and then the item B is pushed onto the stack. So now if you imagine the maximum size of the stack is 3. So next the top value will be now incremented. So now it becomes the value becomes the 3. So here top value is 3 and the maximum stack size is 3. So the 3 is equal to 3, so that it prints the message that stack is full. If the stack is full, then no items can be added to the stack. So here comes the pop procedure. So pop is nothing but the item that is to be removed from the stack. So now we all know which item could be removed from the stack. Yes, definitely the top element only could be removed from the stack. So here you can see that pop, stack, top and the item that is to be removed. So if top is equal to 0, so it means if top is equal to 0, it means that the stack is empty. So then it prints the message that stack is empty. So next, stack of top, the item that is in the stack of top is placed in the item. So next, it decrements the value of the top. So next I will show you how this pop procedure is being taken place in the stack data structure. So here you can see a stack here. So in this the two elements A and B are already pushed onto the stack, and here the top position is here. So next we perform a pop. So what happens, which element will be removed from the stack? Yes, definitely the top position, that is the B element will be removed from the stack, and you will be getting a stack like this. Now again if I perform the pop procedure, the top will be decremented and you will be getting the empty stack like this. Okay, now I hope so it is clear the push and the pop procedure, how it is being performed in the stack data structures. So and here comes the conclusion. As I told you, stack works on the LIFO, or else we can say it as a philo also, that is last in first out. So the operations for the stack are push, pop, is empty and is full. So stacks are useful for designing algorithms to translate and also to evaluate the expressions. So stacks can provide a reversal characteristics. So here comes the summary. So till this we saw what is the data structure, what are the types of the data structure, what are the operations that are performed on the linear data structure, and we saw exclusively about the stack data structure. So operations that could be performed on the stack data structure, and the algorithms, the push and the pop algorithms, and the applications of the stack data structure in our day-to-day life. I hope so you have a clear understanding of what is the stack data structure, what are the operations that is performed of the stack data structure. Any queries? Okay. I hope so you understand the concepts clearly. Thank you very much.